All right, so for the midterm day 2, so on Thursday, you will have problems like numbers 4 through 7 on page 315. Okay. So how would we find the measure of angle 3 on page 315, number 6? That's not quite right, but that's kind of, sort of on the right. Oh, no, just kidding. I was looking at the wrong one. I meant, no, not angle 1. Oh, I see what you're saying. Like multiple steps, doing it in multiples. Yeah, so yes, you could go that route. Yes. So, okay, so yes, you could. That would not get you the answer in one step, but it would get you to the answer eventually. Okay, so yes, you could use the fact that this is a linear pair and find angle 1, right? So the measure of angle 1 equals 180 minus 125. That's true. You could also use the exterior angle theorem. What does the exterior angle theorem say? Not greater than. Equal to their sum. So you could also, to do number 6, say that 62 plus the measure of angle 3 equals 125, and then subtract 62 from both sides, right? What's 125 minus 62? I don't think so. Something 3, but I don't think 83. 63 degrees. So just to kind of prove that we can do it right, what's 180 minus 125? $55 degrees. So this is 55 degrees. What's 55 degrees plus 62 degrees plus 63 degrees? Are you guessing or did you actually do the math? Either way, you're right. It is 180. Right? Easy peasy. Okay? So you'll have to do stuff like that. You'll also have to do problems like 8 and 9. Right? So if we're going to do number 9, where you have to find y, what are we using there? Where's my eraser? Thank you. It kept getting moved last night. The tables are a little bit wacko. They were worse when I came in the door because we had some youth stuff in here because it was too cold to go outside into the patio and all of those things. Okay. So it says in the diagram, triangle RST is congruent to triangle XYZ. And if we're going to find Y, how would we do that?
X plus 21 plus 4y minus 10 equals?
No, no. What theorem or postulate are we using to solve these problems? Let's start with that. CPCTC, congruent parts of congruent triangles congruent. So if congruent parts of congruent triangles are congruent, then what is true about R and X, at angle R and angle X? They're congruent. So if they're congruent, what can we do with them?
4y minus 10 equals 3y
Yeah.
plus 5.
So we could just do, same page, 315, right? Yeah. We could just do number 9, 4y minus 10 equals 3y plus 5. And then that's easy, right? Just subtract 3y from both sides, add 10 to both sides, you end up with y equals 15. Easy money? I haven't gotten to the stuff that you have to remember very well yet. Oh yeah, you have this problem. So you have a problem a lot like number 11. So how would we solve number 11? I'll take a look at it. So that's the problem. What should we do to solve for x? Oh, so close. Millimeters.
Would we first need to solve angles of the wider triangle?
I think that's a great idea. So solve for these angles. So how do we do that?
116 plus x squared or x2.
Well, not x, but because we already have an x. But yes, same idea. Yeah, because it's an isosceles triangle, these are the same, right? So 2 times L, because why not, plus 116 equals 180, right? And then how do we solve that little baby equation? Distributing the 2? I don't think so. It's just 2L plus 116. It's just a 2-step equation, bro. Don't let the parentheses throw you off. How about subtract 116? So 2L equals 180 minus 116 is what?
76. Wait, no, never mind. I am further ahead.
Further ahead. Oh my God. 64. And then we divide by 2. L equals what? 32. So this is 32 degrees. So now what?
We solve the interior angle because 32
Yeah, we're using, if we were to do this in a proof, it'd have to be like some sort of long and drawn out, this one plus this one equal, but we're using angle addition, right, ultimately, and linear pairs. So 32 plus 72 plus whatever that is equals 180. There's not really any such thing as a linear triple, so I can't emphasize enough that if we're doing this as a proof, you'd have to like step it all out, right? But we can use our brain and the stuff that we've done to do all those steps in our head and get to this, right? So what's 32 plus 72?
104.
104 plus something equals 180. Now what?
Sharps.
104. So that angle equals
76.
76 trombones. Great. Now what?
So does the other base angle and then the top is supposed to.
That's all true. So this other one equals, this is also an isosceles triangle, this one's also 76 degrees. So 2 times 76 plus x equals 180. What's 2 times 76?
152.
152 plus x equals 180. So then x would equal
28.
28 degrees. I like that problem. It's a great problem. There'll also be problems like 13 through 16 on the midterm exam. What's the answer to 13? Angle, side angle. I don't think so. That side is not in between those two angles. But you're on the right track. You're seeing the right parts, just not the right order. Angle, angle, side, right? Because the angles and then the side. So angle, side, angle would be if the angle's in between them, right? What about 14? What's the answer to 14? What angle do you know on 14? So not side, side, angle, and that's not even a thing. Side, 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 that's true, because of that reflexive property. What about 15? That's the answer. It's not possible. You can't do it. What about number 16? Side angle side. That's true. You'll also have problems like numbers 18 and 19. A lot from this unit, and this I don't know if you've kind of figured this out based on math and what we've come up with and process of elimination basically. There's only 2 units on the second day. They're also harder, so there it is. But first day has 3. Second day only has 2 units. This one and the next one, units 4 and 5. So there's more per unit. And they're maybe a little trickier, maybe not. So far we're doing pretty well, seems like to me. So what about numbers 18 and 19? Angle 1 is right here. So 18 says measure of angle 1. So what could we do?
Solve the whole triangle all three of its angles by 24 plus 66.
Or since it's isosceles, base angles are congruent.
Or since it's isosceles, base angles are congruent. So what's the measure of angle 1? 66 degrees.
How do you know if it's isosceles? Is it the
Has two congruent sides. What about 19? Which we're supposed to find the measure of angle 2, which is somewhere right here.
Angle 4 equals 132 because the opposite opposing.
66 plus 66 equals 132.
Okay, so you're saying that angle 4 right here is this plus this, which you're right, because the exterior angle theorem, so 132.
And then with the other angle, add them together, you get 156. You subtract 156 from 180, and you get another 20.
Which means this one's also isosceles because of the converse of the something. Great.
How many proofs are going to be on the next?
We've already seen the closest thing to a proof that's going to be on this test. Well, good. If we were going to have a proof, it would have been from this chapter. Now, the closest thing you're going to have to a proof is 13 through 16 there. Where you have to be able to be like, okay, I can prove it with this. All right, chapter 5. This is the one that you should probably spend the most time studying. In my humble opinion. That, now, I should emphasize, with a little bit of emphasis on the syllable, that just because I'm saying you should spend the most time studying this doesn't mean you shouldn't study the other stuff. It is a mistake to be like, oh, this is easy. I got this. If you're like that, great. Spend a few minutes studying that thing and then spend some other time studying the other thing. Don't just look at it and be like, oh, this is easy. Don't do that. Learn from your past mistakes. Okay. We will have stuff like 2 through 4 on page 385. Okay, so on 2 through 4 on page 385, we have a triangle that looks kind of like this.
What's the difference between that centroid and incenter?
Well, that's kind of the direction that I'm going to be asking questions about. Good job. So it says that K is the centroid.
Bless you, thank you.
I don't know. I think I'm too old. The thing is that I understand sometimes, many times, not all the time, but many times, where things come from. I just don't understand why the cultural zeitgeist has become memes. I just don't understand. I'm too old. Too many gray hairs. Anyway, it says that K is the centroid. What the heck is a centroid?
It's one of the lines.
All of what lines? Which ones?
Is it a bisector?
Which kind of bisector?
Angle bisector.
Angle bisector. Is it angle bisector? So that's the question. Is it angle bisector? You're going to have to go back in your notes and look it up. Or in the book. That also works. If you're like, oh, I don't have notes because I don't do that. Well, you know, you should fix your life, but then also.
It's the median, so it's like.
So it's the medians. So the centroid is where all the medians cross. What the heck is a median? That one's easy because it sounds like what it is. I'm just saying.
It goes from the vertex to the midpoint of the.
Yeah, vertex to the midpoint, right? So vertex to the midpoint. So this is congruent to this, and this is congruent to this, and this is congruent to this, right? That tells us great things. Now, we also know this is 12. Now, so that's all great. All of that's wonderful. We love that. We're happy about it. What's the centroid theorem now?
The longer side is 2/3 and
Of the
line.
whole thing, right? So it says the one from the vertex of the centroid, which is the long one, is 2/3 of the whole thing, right? So like for number 2, where we're supposed to be finding the measure of KH, right? Yeah. Measure of KH
We're given that dk equals 16.
we're given what?
dk equals 16.
Oh, nice. We're given that the measure of D to K equals 16. We're also given that GD is 9. Great. So the measure of KH. So how could we do that?
You multiply it times 1/3.
So the relevant equation is the measure of dk equals 2/3 the measure of dh. That's the relevant equation from the theorem. Now, there's shortcut ways to get answers on these problems. I don't care whether you use the shortcuts or not, but you know, whatever. So we know this one is 16, right? So how do we solve for 16 using this equation?
16 is
What?
you have 16.
You multiply by 3/2, which would be halving it and then timesing it by 3, right?
Maybe.
How is the 2/3 attached to the DH? Let me go back and ask it a different way. Multiplication, how do we get rid of it?
Multiply by the reciprocal.
We divide it, and how do we divide fractions? Now your answer is up. Multiply by the reciprocal, yeah.
That's what, it's the same thing.
Yeah.
Okay, yes, but the steps do make the same thing, therefore.
I gave it to you. I just had to walk the step to get to where your brilliance lied.
Brilliant.
So the measure of DH equals 24. So that whole thing is 24. KH is 1/3 of that. What's 1/3 of 24? What's 1/3 of 24?
So 8.
8. So we were looking for this one, yeah? No, it doesn't. Stop, calm down.
It's not complicated, but it's just, are we doing it the complicated way?
We're doing it the way that fits the formula. Now, what I was going to say before you interrupted with, I'm confused why we're doing it this way. Because we're doing it this way because this is the formula that you need to memorize. Now, if this is 2/3 and this is 1/3, then this is half of that, always. And this is twice that always, right? Just because math, right? So like this is 6, right? So that's what I was saying. There's shortcuts to be able to do it quicker on a lot of these problems. But this is the formula. This is the way the formula works, yeah? The point, the vertex to the centroid is 2/3 of the whole, right?
If you had like KH, would you just turn the 2/3 into 1/3? If you had
Yeah, you could. You could. It's not really the theorem, but it's, you're not doing a proof, so that's just math. So yes, that's fine. What about number 3, where you're finding the measure of CD? What would the measure of CD be?
9 times 2.
18.
18. It's 9 times 2. That's right. Easy money, yeah? What about FG?
18.
9 times 2.
No, FG wouldn't be 9 times 2. So FG is this one. 12 is 2/3 of FG.
So it's 12 plus 6.
So it is 12 plus 6, or it's 12 times 3/2, either one, yeah? Either way, you get 18, right? Number sense, it's useful. This, by the way, all this that we're doing, all that you're doing in your brain right now, all the turnings of the wheel and all of the things where you're flipping stuff around and all of that stuff, that's why you learn geometry. So that your brain gets better at doing that. Just so we're clear, right? You're never going to have to care ever probably in your life again what the heck a centroid is after this test. Probably not. But that's not the point. The point is being able to pull things apart and put things back together, use principles to build other ideas and all of that. Making sense? Y'all are so sleepy-faced. We'll also have stuff that is like 10 through 13. I like these ones better. These ones make me happy. They're fun. Not as happy as the next unit in pre-cal. That's the best ever. So much fun.
Take your word for it.
It's going to be great. They're going to love it.
I don't think they're gonna, for some reason.
I don't know. It's the best. It says point H is the in-center. I'm going to try my best to draw the in-center. It's going to fail miserably, but let's see what happens. What is the in-center while I'm getting this drawn up there?
Conjunction of all angle bisectors.
All of the angle bisectors. That's true. What's an angle bisector?
Bisects the angle.
That's true. So this is the same as this, and this is the same as this, and this is the same as this. What's true about the in-center of a triangle? Yeah, it's equidistant from all the sides, right? So that tells us that this is good to this is good to that, right? That's handy, right? So, how would we solve number 10 where we're trying to find the measure of DH? Where is D? H is right here, and D, F, G.
So we did 28 plus 90 plus DH are that
So the problem with that is you're talking about angles and we're looking for a line segment. So we can't go that route.
Could we do?
So here's where you got to go in your head. Where do we know about line segments? What do we know about any line segments on this thing?
One of them's 25.
Yeah. So this one's 25 and this one's 11 and
There.
you're missing a whole line segment, guys.
AF is 24.
AF is 24. So can we use any of those to find some other side?
We could do Pythagorean theorem to solve for FH.
We could use Pythagorean theorem to solve for FH. The measure of FH squared plus 24 squared equals 25 squared, right? Easy money. What's 24 squared?
576.
What is 25 squared?
625.
Now what?
Square root everything.
No, not yet.
Subtract 576.
What's 625 minus 576?
49.
49. And then what?
Square root everything.
Square root everything. So the measure of FH equals plus or minus 7, but we're talking about distance, so we're going to chuck set the minus one in the bin, right? So this is 7, which means DH is what? 7. Look at us doing things. Now what? Find BD. See?
We could also use Pythagorean theorem to solve it, right?
We could, because we know that this is 7. So we could use Pythagorean theorem again, right? Or again, if you prefer. So the measure of BD squared plus 7 squared equals 11 squared, right? What's 7?
How do you know which one's A and B?
So the only one that matters is the C, right? Because it's the only one that's different, and it's always the hypotenuse. So always the one across from the 90-degree angle, always the longest one. Okay? So what's 7 squared?
49.
What's 11 squared?
100.1.
Okay. Now what?
Subtract 49.
Subtract 49. That's true. So the measure of BD squared equals what?
72 squared.
Not squared.
Right, 72.
Now what?
Square root it.
Square root it. What's the square root of 72? I don't think exactly 8.
If it's rounded.
8.5. approximately 8.5. Grand, glorious. What about the measure of angle HAC? HAC, so this one. Let me change markers real quick. So this one. This is my favorite kind of problem on this one. This one right here.
Okay, so 30 plus 30 plus 28 plus 28. Add whatever those equal, and then you subtract it from 180, and that equals those two halves. And you cut it in half, and that's it.
Okay, so yeah, everything you said is right. So this times 2 plus this times 2 plus this times 2 equals 180, because those are all angle bisectors, right? So the full equation would look like 2 times 30 plus 2 times 28 plus 2 times the measure of HAC equals 180. What's 2 times 30? 60. What's 2 times 28? 56 plus 2 times the measure of angle HAC equals 180. Where are they? 60 and 56. What's 60 plus 56?
111.
Definitely not 111. 116.
DHG.
Why are you saying DHG? What is happening with your mouth right now? What is your question? Are you looking at the next problem or something? Or gotcha. Okay. Don't make the mistake and try to combine that 2 over here. That's like Bush League stuff. Don't make that mistake. This is not like terms, right? What would we do now?
Subtract 116.
Subtract 116. 2 times the measure of angle HAC equals what? 64. And then divide by 2. So the measure of angle HAC equals 32 degrees. The last one on those problems is the measure of DHG. Okay, which is DHG, so this one, right? Not really.
So it's 30 plus the 30 plus the 90 plus the 90. And, well, no, the 30 plus the 90.
Okay, so you're going for the quadrilateral instead of the triangles, right? That's fine. It's great. I like it. It's a good idea. Yeah, because you're saying this plus this plus this plus this.
Oh, no, that's not what I meant.
Oh.
I'm sorry.
Well, that would be fine. I love that idea. That would like be less steps, although that's kind of using this unit to go back in time, but that'd be fine.
30 plus 90 equals 120, and 180 minus 120 equals the 40. 40? 60 of that angle, and you add them together and you get.
What?
Real.
What are you saying?
So take the 30 and the 90 from B
Yeah.
and G,
B and G.
angle HBG and angle HGB.
Okay.
You add them together, you subtract that from 180.
Which gives you this one.
Yeah. And then you add it to the other side.
To what other side?
You times it by 2. You
It's not that's not an angle bisector.
I know, but the other side also has 30 and 90.
Oh, I see. I see. Yeah, that's probably true. I like the quadrilateral better, but you know, whatever. How many is the sum of the interior angles of a quadrilateral? 360. So 30 plus 30 plus 90 plus 90 minus 360. So either one of those works. You could find between the two of us mumbling through stuff, we talked about two different methods for getting there, plus the quadrilateral method to get there. There's all kinds of ways to get there. You could find this one and then get this one and add it to that one. You could also realize that these are the same and these are the same. So that means that these have got to be the same because we'll learn about that later, but similarity, angle-angle similarity, which means the angles are congruent. So any of those methods will get you to the fact that that is 120 degrees if it's 60 plus 60. Because it's a 30, 60, 90 triangle. Trigonometry. Yay.
I like 3, 6, and 9.
3, 6, 9, monkey drank the wine. I don't know, something about a toy boat, however the rest of that song goes. I don't know, something. And believe it or not, young men and young women, that's all it's going to be on Thursday's test. That's it. Y'all have seen all the things. We saw stuff on Tuesday. It's going to be on Tuesday's test. Stuff that you got today is going to be on Thursday's test, and that's it.